Now, one interesting question here is, whatever the algorithm we have used, what is the time complexity? Let's recall the algorithm. What is the algorithm? In our algorithm, what are we doing is, we are taking a stack which is empty initially, and whenever you see an operand, that means you are processing a string. Okay, I assume that the string length is n. Okay, there are n characters in the string, either one, that is operand or operator. Now, whenever you see operand, what are you doing? You are pushing, correct? So that means there are some push operations, correct? Now, whenever you see operator, then we are removing two elements. That means we are doing pop operations and we are doing the calculation. Once you pop them, we are doing the multiplication or division or anything. My assumption is multiplication or power operator or otherwise minus, everything takes, let's say, constant time. If that is the case, then the overall time complexity of this algorithm, you see, for every symbol, either you are pushing, otherwise you are popping, correct? Right. So when you see operator, definitely you are popping two elements, correct? Then what if every symbol is operator? Let's say that is the worst case, because if it is operand, that will be easy. Simply push. It takes only constant time, correct? Let me analyze the time complexity in the worst case. In the worst case, what I assume is, let's say if every symbol is operator. Of course, that is not the case at any time. But what if everything is operator? Then what happens is, we remove two elements, we do two pop operations. Let me analyze the time complexity for one particular symbol which is operator. Okay, then we pop and again we pop. This is, let's say, pop 1, this is pop 2. Then you perform the operation. Now, what is the time complexity of all of these? Popping first time, constant. Popping second time, constant. Sir, how can you say that? Just now I taught you stack. In that stack, I told you that, pop takes constant time. That's why constant, constant. After that, what are you doing? We are taking that written values of that pop and we are multiplying them, correct? Then that multiplication takes again constant time. Overall, so we have constant time, right? Now, so whenever you see an operator, we are spending constant time. Now, in this entire algorithm, what is happening is, we are scanning every symbol. If every symbol is operator, still we are spending constant time. If it is operand, still we are spending constant time. Then I can say that whether it is operand or operator, we are spending almost constant time. Then how many such constants we are spending? N. That's why, because there are n symbols, n into, so for each symbol we are at most spending constant time. Then that will be n into constant, isn't it? Now, final answer is some n into constant, c into n. Whenever a program's running time is c into n, it's like 2n, otherwise 3n, maybe 100n, doesn't matter. So all these things, 2n, 3n, 100n, whatever your answer, that is theta of n, isn't it? Already in asymptotic notations I told you 100n or 500n also said to be theta of n. Some students ask now, sir, can I say order of n? For that kind of students, I will ask only one question. Okay, your program's running time is some constant into n, right? Whatever may be the constant. Is that Cn is order of n? That is what you are asking. Okay, in asymptotic notation already I told you, any constant into n is order of n. That's why it is correct. That's why if you have strong foundation about asymptotic notations, then you never need to ask these questions. It is like asking, sir, my program's running time, algorithm's running time is Cn, sir. Is it theta of n? Absolutely, because Cn is nothing but theta of n. In asymptotic notation, Cn is nothing but said to be theta of n. Cn also said to be order of n. Now, one more stupid question students ask, is this Cn equal to omega of n? Yes, because mathematically Cn is nothing but omega of n. Finally, I can say that when in this algorithm's time complexity, order of n, theta of n, omega of n, everything is right. Understand?